Okay, uh, in the last video, we learned how to calculate the confidence interval. In the end, it was pretty simple. And let's think about this. First, the confidence interval is always centered at x bar, and there is plus minus margin of error. So when x bar increases, so when x bar changes, it's moving parallel, right? The point estimator is always the center. So if it changes, the margin of error is not affected, but the interval moves parallel. And now let's think about the standard deviation. If the standard deviation increases, that means a single outcome has larger standard deviation, which means data have more noise, more variability, more dispersion, more inequality, more uncertainty. We can think it in many different ways. So anyhow, there is more noise in the data, so you have to allow more marginal error. So on average, the error will be larger because the outcomes vary a lot. So the interval has to be widened. That means the margin of so high if s increases, it changes only the margin of error. So that means the center is the same, but the margin will increase. So the interval will be wider. And now then if you think about the sample size, the more sample you have, that means you have more information, which is nice. So you can do more accurate analysis, which means you can reduce the error, so you can reduce the margin of error. So the margin of error is inversely proportional to the sample size. So the higher the sample size is, you can reduce the margin of error. So the interval will narrow down. But as before, the center does not change. The location does not change unless x bar changes. And finally, z alpha over 2. Z value directly depends on the confidence level. So if you choose 99%, it will be bigger because to cover higher probability, you have to extend your interval. Or if you decrease the confidence level, then z alpha value will shrink. So the interval will shrink. So the z alpha over 2 will be reduced accordingly. So these four components show how the trade-offs and the accuracy and how they work within each other. And this is a summary, very nice kind summary for you for typical confidence levels. So typically 3 confidence levels are commonly used, and the most standard is 95%. But it depends. So these 3 are most standard ones, and 90% confidence level implies 10% error probability. The error may happen with 10%. If you don't like this much error probability, you can change, right, to 99 or 95%. So the error can happen with 10%, so each side has 5%. So overestimation error will be 5%, underestimation error will be also 5%. Therefore, the endpoint, the upper limit and lower limit should be like the upper limit should be the top 95% value, or excuse me, top 5% value, or its cumulative probability must be 95%, right? So the 5% is outside the upper limit, and the other 5% is lower than the lower limit. And then top 5% value is usually very, like in most textbooks, it's given. Like many tables show you what is the 95%, why the number corresponds to 95%, or top 5%. So this is 1.64. this number, many people memorize this number because it is so commonly used. These three numbers are so common, so there are a lot of people just simply memorizing these numbers. Not a bad idea, but you have a calculator, so you don't need to, or you can just open up the slides to see what's the corresponding number. And as you see, the confidence level increases, z-value should increase, right? Z-value should increase because to increase the probability, the interval has to be wider. And so, as a result, z increases, and then the margin of error also increases. So, in the end, you have to understand the trade-off between confidence level and margin of error. And then you need to maybe like this result is so useful, so it's worth memorizing. Or you don't need to, but many people memorize that because it's so commonly used. Okay, here is an example to apply that result. So I made up an recent example about COVID-19, but has virtually nothing to do with COVID-19 thing. I made this slide last year, and last year was my first online teaching on this section, on this course. So I did not have enough time to reflect the COVID-19 examples elsewhere. But now I think I can update many examples with COVID-19, like conditional probability, or like here, or maybe next year. Anyhow, let's think about this. Think about, again, there is an insurance company. An insurance company, say, I don't know how, like, I don't know how the cost of COVID-19 treatment is shared between the government and the hospital and the insurance companies. But just suppose that there is an insurance for COVID-19 treatment costs. So what you have here is the insurance company wants to estimate the expected cost of COVID-19. And the company has 100 random sample of 100 COVID-19 patients. And their average per patient was $20,000. For example, of course, it's a fake number. And the standard deviation among the 100 patients was 5,000. And the company wants to estimate the expected cost with 99% confidence level, right? I'd like to make an interval with 99% probability. So how can we calculate that? It's pretty simple. You do not need to derive everything again. Just take the result. Take the result, and we know this. This is given. Average is given 20,000. Standard deviation is given 5,000. Sample size is given 100. So square root is 10. And then the only thing you need to calculate is this guy. Z value, Z alpha over 2. Here in the question, the confidence level was set as 99%, which means like this, you are looking for this guy. That's just notation. So you are looking for top 0.5% value. Top 0.5% because error probability is 1%. So the overestimation probability is only 0.5%. So you have to find a value that satisfies this probability. And you may simply just take this number, 2.58, right? 2.58, approximately it is 2.58. Then you know all the numbers. This. This is it. So first, calculate the margin of error. Margin of error is z-value times standard deviation divided by square root of sample size. So calculate that. 1,290. And from the sample average, add and subtract. Then you get these numbers. the confidence interval is given by this. That means the expected cost of a COVID-19 patient is estimated to be between $18,710 up to $21,290. It must be somewhere in between them. So that probability is 99%. This estimator will be correct with 99% probability because that's the probability we set here. So this is how we use the confidence interval. As you can see, the derivation was more complicated, looked more complicated, but actually application is pretty simple, right? Just get used to that. And I'll give you an exercise. You need to try pretty much the same question with different confidence level. So using 90% confidence level, try to find the 90% confidence interval. You may use this number if you cannot find this outcome, this value, right? So pause the video and do it by yourself, do the exercise, and I will show you the answer. Everything is given. So as standard deviation was 5,000, sample size was 100, and z value is now 1.64. It's now different because confidence level is now 90%. So it should change. And then the margin of error calculated simple, and then add and subtract the margin of error from the sample average, 20,000. This is it. This is how you calculate a confidence interval. So this is the results. If you use 3 different confidence levels using the same numbers, given the same data, if you apply different confidence levels, you are going to get 3 different confidence intervals, and you see the interval increases. So lower limit decreases and upper limit increases. That means the interval will get wider as confidence level increases. So the interval increases, widens as the confidence level increases. I will call it a lecture, but let me introduce what we are going to do in the next video. So, okay, we learned how to calculate confidence interval given a confidence level. In the end, we learned we want to have higher confidence level and smaller margin of error. And I said they are trade-off, but actually there is one way to achieve both. That is to collect more data. So if you can increase the sample size, then you have more information, so you can do better. You can do better at every dimension. That is possible. But so this is an important starting point of the experiment design or survey design theory in statistics. It's a field in statistics. So you need this a certain level of accuracy, then how much data you have to collect, or if you have like a cost of survey, then what is the optimal balance between survey cost and accuracy, benefit from higher accuracy, something like that. So it's experiment survey design problem, and we are going to find how to set the optimal sample size when you analyze something, when you estimate something. Okay, thank you for watching, and next time I'm going to finish this chapter, and maybe in the next lecture I will start the next one, which is about hypothesis testing. Okay, see you later.